What happens when your VoIP calls keep dropping during peak hours? Or when your video conferences freeze at the worst possible moment? The culprit? Network congestion, ruining your real-time traffic. In this video, I'll show you how quality of service, QoS, can prioritize critical traffic like voice and video, ensuring crystal clear calls and buffer-free streaming. Stick around to the end where I reveal the 3-level QoS strategy that Fortune 500 companies use. QoS, quality of service. In the networks, there is a mix of data, voice, and video traffic. Each type of traffic has different properties. Data is not real-time traffic. That is to say that the data can arrive late or even not arrive necessarily in the right order, that it is not a big deal for this type of giving. For example, applications or email are not delay sensitive. Unlike apps, they use databases, which are very sensitive to delay because users expect answers. Voice is real-time traffic, which must have a constant bandwidth because it has limits that must not be exceeded to receive packets, and the video that includes several traffic subtypes. We have passive video, like streaming. There is interactive video, which is a real-time stream, and also video conferencing. All of these types of traffic have requirements that can vary on bandwidth, delay, and packet loss tolerance. Video has the same delay, jitter, and delay requirements as voice traffic. The only difference is in bandwidth, as voice packets are very small, while video packets can vary depending on the quality. Streaming video, on the other hand, has different requirements than video conferencing. For example, an employee who is watching a learning video will not be sensitive to the delay or packet loss than a live video conference, because in streaming, or even any video you watch on the internet, there is a buffer, that's to say, a style of buffer, which runs to compensate for any transmission delays that could occur. The term QoS, quality of service, refers to the ability to provide a service that complies with certain criteria of requirements in terms of response time and bandwidth. It must be able to guarantee an acceptable level of packet loss for a data type. For example, the requirements for VoIP will be different from video conferencing. QoS only applies on networks that use routers or switches because it is impossible on the internet to predict the path that the different packets will take. That is to say, there is no guarantee that communication will be able to take place without problems. Well, that's where QoS comes in. It makes it possible to differentiate between the different network flows and to reserve part of the bandwidth for those who require an uninterrupted service. 3-level of QoS service. We have the best effort, which makes no difference between several network flows and which gives no guarantee. We have the soft QoS, which allows you to define priority levels for the different network flows. But just like the best effort, there is no guarantee. And we have the guaranteed service, which reserves network resources for certain types of flows. In the QoS, there are 4 important criteria that make it possible to make the different levels of service work. There is the speed, which is often called bandwidth. It is the amount of data transmitted during a certain time. The throughput here is expressed in bits per second. There is jitter, which is the variation in latency. This is very important for apps that transmit voice or video. There is latency, which focuses on the delay between the transmission and reception of a packet. And we have packet loss, which is simply the non-delivery of a packet of data. This can happen if the network is congested.